Hello, students. Today we are looking at rotations and compositions, and we have a guest teacher, which is Winston, who will not get off my lap currently and was just confused about why I was talking.
Will Winston start barking at us at some point?
Probably.
That would be exciting. What if I bark at Winston at the end of the video?
He may reply or he may just kind of look at you.
Well, actually, he won't hear me because it's through your headphones.
He'll
Okay.
hear it anyway.
Okay. So we've got rotations. The point 3,2 is rotated counterclockwise. What's counterclockwise?
Well, I know that when I look at my watch, because I have an analog watch, the dials go this way. So I'm guessing that's clockwise.
That is.
That means that counterclockwise is going the opposite way.
If I were at school, I would draw on my clock this information.
It's true.
Keep it straight for the students. But
You've also drawn on my clock with that information.
I didn't want them to get confused, but it's also in the picture. So it's in the picture going counterclockwise. So if we rotate 90 degrees, 3,2 winds up at -2, 3. Now, the easiest way to rotate is to take a picture of that. I mean, not take a picture, but just like physically rotate whatever you are talking about. So feel free to make use of that when you're talking about, like literally rotate your Chromebook or whatever you are using to figure out where the rotation goes.
Wait, so you mean that there are some rules that they're hinting at here that they don't have to memorize if they just spin things by hand?
Yes.
Cool, I like it.
There's a lot of words there. I'm going to let you talk about that. Whew.
All right, so this is defining what a rotation is. It's saying that we're rotating X degrees and calling something a center of rotation. This year, are we doing anything except around the origin? I don't remember.
Focusing on the origin, we're only doing 90, 180, 270.
So we don't really have to worry so much about what happens if we want to rotate around a different point. Our center of rotation is generally going to be the origin itself. And we're talking about if you started at T and then you spun that point by 90 degrees with the center of rotation at the origin, you end up at T prime. Same thing for V. If you spun this 90 degrees around the origin, that would be 90. You'd end up at V prime. And the same thing would be for you. I'm not going to add that because it's going to make the diagram even more messy. The other thing that we'd like you to notice here is that when we are talking about rotating by X degrees, I don't even know why I said 90 because that's not 90 degrees. When we're rotating by X degrees, we are rotating counterclockwise for a positive rotation. That's just how it's defined. There are some reasons for that, but we don't need to go into that in this class. We kind of talked about angle of rotation, and here is the notation that is used in this book. And just like we've said before, this is not universal notation. This is notation that's just based on this specific book. So if you want to do this in words, cool, we like that. All right, we're being asked to find a graph of rotation 90 degrees. This O is the origin. And it looks like that has been done. Is that fair? Okay. And just to kind of talk about the way that we were advocating that you do this. So if this is the point, I'm just going to call this, I don't know, that looks like 3, 3 to me. That's. But then when we rotate this 90 degrees, and I was looking at Q prime's new coordinates would be 1, 2, 3, 1, 2, 3.
So you're going to say 1, and I got very confused.
-3, 3. Yeah, I was still on the move of the image tool instead of the drawing tool.
Oh, so you got confused. So you're saying all I need to do is rotate that image and then kind of rethink things. So I can say, these are my new axes right here.
Hmm.
Pretend this is X and this is Y. So this point here is -3, -3, 3.
And like
And
this
then,
point here would be -1, 1.
and then so if I write those down, -3, 3, -1, 1, when I go back to normal orientation, erase all the garbage I just did. Can you rotate while I'm erasing? That's exciting. Um, then, well, it caught up eventually. Then we could just plot those points. So -3, 3, -1, 1.
And as we said, they've already done that here. But that's by far the easiest way to do this. Any other way to do this, to be honest, it hurts my brain to think about. My brain does not deal well with rotations. I know the same is true for Mr. Butterworth. The same is true for the teacher we worked with last year, that getting our brains to deal with rotations in some kind of a meaningful way is really hard. Rotating the paper or the picture on some kind of a computer makes that really easy for us.
You will have to do a little bit of not fancy rotation, but different kinds of rotation on Khan Academy. But use their tools, and it's
Mm,
pretty clear what's going on. If you're struggling using their tools, touch base with us, and we can clarify how to use them because
that's true.
they're a little bit bizarre, but they're pretty nice to use. So
All
this one, it
right.
says rotate 270. So we can do the same thing Mr. Carl was talking about. We rotate 270. Make sure you're clear which way you're going to go. So we're going to rotate counterclockwise. So 90, 180, 270. I had to let go
One.
of the image. There we go.
Oh, there we go.
Did I do that? Okay.
Yep.
So what I would now do is write down the points. So I have F, G, H, and I.
Mm-hmm.
So I is now at the point 1, 0. And I suppose I should
I
call it
agree.
I prime. F is at the point 2, 3. Suppose I should call that F prime. H is -1, 1. And then G is -1, 3. So once again, we're rethinking the axes there. So this says Y right there, but I'm pretending that that's now the X axis. So reframe how you're thinking. And you don't have to physically rotate it like that. But as Mr. Carlson said, we think it's probably easier. So then
Yeah.
we rotate, almost back.
The traditional way to do this in a lot of schools and courses is that there are like specific how the X changes, how the Y changes rules for each of the 90-degree rotation family. And a lot of times they'd have students memorize what happens each time, because you might notice that the coordinates look like the same but a little bit different, and that's a really predictable thing. It's also such a waste of like brain space if you're memorizing that stuff instead of just kind of physically manipulating it.
And I don't have that much brain space to fill. So
Nope.
that's, that's not bad.
Wow, that was pretty good.
I missed. Whoopsies. So then once I went back to normal orientation, I just drew the points again, and that's all there is. And you can do that on a Jamboard, obviously, because we just did. You can do that on your quiz. It's not too scary.
All right, so now we have the activator in the middle of the slides, and that's because we're combining rotating things with then doing more than one transformation at the same time. So while Mr. Butterworth is kind of writing these things, what we're going to do is to first reflect this over the y-axis. That's the first instruction that we're being given. There we go, I fixed that.
Did you throw everything away?
No, I just don't, I moved the grid so it was a little bit off from your points that you very carefully drew. And then after you do that reflection, we're going to do a translation of the new image to make a second image.
That's the key. The new one, not the old one, the new one.
And I noticed that because within my translation, it's talking about triangle A prime, B prime, C prime instead of triangle ABC.
Oh, I shouldn't have circled that in red. What color are you going to do it in?
I don't know, green, I guess, because that's what I have open.
Sounds good. Green.
All right, so if I've got B prime is going to be right there. It just went directly across the y-axis. We do the same thing for A to get A prime, and 1, 2, 3, 4, 1, 2, 3, 4 for C prime. So that's my first transformation. For my second transformation, I'm going to switch over to blue because I see this is a translation. And when I see the -2 for the x, that means I'm going to go 2 to the left. And when I see the 4 for the y, that means I'm going to go 4 up. And again, I'd like you to notice we did not use the word over at all in that. 1, 2, 1, 2, 3, 4. Here's B double prime. Then we've got 1, 2, 1, 2, 3, 4. C double prime. And then 1, 2, 1, 2, 3, 4. A double prime.
Went up 4, right? So -4, 8 is what B is. Did I do that right?
That seems pretty reasonable to me.
Sweet. Just trying to add some details as we went.
I like it. So now we're dealing with this delightful notation that isn't awful at all, which gives us instructions on how to do multiple translations together.
And I always caution you about which one to do first. I'm just writing down what these things mean. So the big R means reflection. X equals 0. That's when X is 0. So that's the y-axis. I wrote that on a previous page. And then this one means translate. And that's going to be just down 5. We don't go anywhere left, right.
And I know in algebra, we work from the inside out with things that you do together. I think we do the same in geometry.
Yes. So I regret how I wrote that because I wrote it in the opposite order. So I'm actually going to do the translation first.
So it's like you're saying that, I'm going to write in red so it's different, that this part is done, and then whatever we get as an answer, we do this too.
Yes, I prefer to not use that dot notation, but to use the parentheses because it makes more sense.
It's true.
So we're going to have to move down 5. Now, I don't have a good picture here, a good graph to play with, which is unfortunate.
That's also true.
So I'm going to have to think a little bit about what we're doing, unless I use my magical powers to make a graph show up.
What?
What I did there? All right.
You have such magical powers.
So I'm going to go ahead and plot the first thing. So I'm going to have some axes. And then -2, 1 is my original figure. I'm going to make my original figure in black. -2, 1 is my original. -1, 3. And then -5, 2. And Mr. Carlson's making sure I know how to count and talk at the same time, hopefully.
You're in good shape.
All right, and now we're supposed to move down 5. So move down 5. So 1, 2, 3, 4, 5. Now I'm going to be lazy. I'm going to assume I got that one right, and I'm going to use that point to get the other one. So I'm going to verify I did that correctly.
That looks
wonderful. What I did is I looked at the slope basically between x and e, and the slope between x and t, and built both e and t from x once I moved x. So I didn't have to count 5 for each one. I counted 5 for x and then used slope because the figure has to be the same. We've talked about that. Those figures have to be congruent. It's a rigid transformation or rigid motion. And then
the reflection, we said x equals 0 is the y-axis. I'm just going to draw this and let you kind of do the mathy parts inside the last one. So that's our y-axis.
And so, I didn't know where you're going to stop. So that was fun.
No, that's all I was doing. That's it.
So E is 1 away to the left, so we're going to go 1 to the right.
Hmm.
X is 2, so I'm going to go 2. And I could do the same idea with slope, but I'd have to think a little bit, and that's scary. So that's 5. So 1, 2, 3, 4, 5. So all I'm doing is measuring how far it is. And then that's my figure right there. And we did it.
Woohoo!
We will, in general, not use that notation. And that's all there is. That's all we did for you.